Okay guys, so this is going to be graphing piecewise functions. So a piecewise function is just exactly what it says. It's a piece of a graph with certain boundaries, okay? So we're gonna go through this kind of slowly. So what we're gonna be doing is making a lot of T-charts. So I'm gonna take the first branch, the top branch, y is equal to x plus 5, and I'm gonna make a little T-chart. Okay, now it says I'm going to start at -2, and I'm going to pick values less than -2. So I'm going to pick -3, -4, -5, and -6. Okay, so I'm going to plug in -2 plus 5 is 3, -3, 2, -4 is 1, 0, -1. Now there's no equal to sign underneath this part, so it's going to be open. It's going to be open circle. So I'm going to plot the point -2, 3, 1, 2, 3 with an open circle. And I'm going to plot -3, 2. And it's going to go down like that. And I'm going to hopefully have a straight edge when we're doing this. It'll help. Use a credit card or use your driver's license as your straight edge. Okay? So that's what that branch of the graph looks like. Now, the next branch is y is equal to 2x minus 1. And I'm going to start at -2 again. -2. Now I'm going greater than -2, so -1, 0, 1, 2, and 3. Okay, so I'm going to plug in -2. -2 times 2 is a -4, minus 1 is a -5. Okay, -2 minus 1 is -3, -1, 1, 3, and 5. Okay. Now this is going to be a close point at x is equal to a -2 because of the equal to sign. So I'm going to write closed, just so I know. Okay, so I'm going to go to the point -2, 5. -2, -5. 1, 2, 3, 4, 5, like that. And I just want a few points. Try and make this as neat as possible. It doesn't have to extend all the way out if you don't want it to. Something like that is what it looks like. Okay, and that's how we graph piecewise functions, no matter what. Okay, and next one, we have y is equal to 2x plus 1. And we're going to make a T-chart, or a table, however, whatever you like to call it. I call it T-chart. So we're going to start with values greater than or equal to 1. So 1, 2, 3, 4, 5. Okay, plugging in a 1, we get 3, 5, 7, 9, and 11. Okay, since there's an equal to sign in this branch, this is going to be closed at 1. Okay, so let's go ahead and plot these points. 1, 3, 1, 2, 3. Up 2 over 1, 2 over 1, up 2 over 1. So that's something like that. Where's my ruler? I got it. So it looks like that. And then the bottom branch is y is equal to 1/2 x minus 3. And we're going to make a T-chart. We're going to start at 1. And we're going to go less than 1. Okay. So plug in a 1. 1/2 minus 3 is -5/2. 0 minus 3 is -3. -1/2 minus 3/2 is, I think, 7/2, -7/2. Let me just double check to make sure. Yeah, And then this is going to be negative 8/2, which will be negative 4. And then this is going to be negative 9/2, like that. Okay, so this is going to be an open circle because it's not equal to in this branch. So if you didn't want to deal with the fractions, you don't have to. Like 1 negative 5/2. 1 negative 5 is 2.5. So we're going to guesstimate it like that. 0 negative 3. Like that. Let's plot negative 2 negative 4. Okay, so it'll look something like that. Okay, it doesn't have to be perfect. We're just looking for a decent sketch of this. Now, as you can see, these limits won't exist at 1. So what we're building up to is to proving continuity and graphing. So we'll do that in the next lesson. You'll have to graph piecewise functions and prove the continuity using limits and all that other good stuff. Okay, next one. We got y is equal to 2x minus 2. Okay. And we're going to start at 2. So start at 2. So 2, 3, 4, 5, and 6. So 2 times 2 is 4. 4 minus 2 is 2. 6 minus 2 is 4, 6, 8, and 10. It's going to be closed because of the equal to. And then I'm going to take y is equal to negative x plus 5. And I'm going to start at 2. And I'm going to pick values less than 2. Okay, so negative 2 plus 5 is 3. Negative 1 plus 5 is 4. 0 plus 5 is 6, 7, like that. Okay, so we're going to go through, and I didn't plot these points first. Let's go through and plot these first. And this is going to be open. Okay, so the point 2, 2 is closed. 3, 4. Okay, so it's going to look something like that. And negative x plus 5, we're going to start at the point 2, 3. Let's see, 1, 2, 3. So it's going to be a tight squeeze there, so just make sure you're paying attention. And then 1, 4. Okay, so it looks something like that. Okay, and they don't meet up, so the limit wouldn't exist there. Okay, now this one we have 3 branches. Well, it's not a big deal because it's just 3 Tcharts. Okay, so let's do the first branch. Y is equal to negative x plus 4. And we're going to pick values less than or equal to 0. So 0, negative 1, negative 2, negative 3, and negative 4. Okay, plug in a 0, you get 4, 5, 6, 7, and 8. This is going to be closed because you have the equal to. Okay, so you have the next one, y is equal to 2/3 x minus 1. And I'm going to pick points in between 0 and 5. So 0, 1, 2, 3, 4, and 5. Okay, so if I pick a 0, I'm going to pick, it'll be negative 1. 2/3 minus 1 is a negative 1/3. 4/3 minus 1 is 1/3. 6/3. So it's 2, it should be 1. Yeah, so 5/3. And then 7/3. 10/3 minus 1, 7/3, yeah. Okay, so realistically, we're just gonna probably plot these 2 points right here because those are our good points. So this is gonna be open, and this is going to be closed at that point. It's closed because the equal to branch right there. And then the line y is equal to 2 for x is greater than 5. Okay, so this is just going to be the line y is equal to 2, so the horizontal line. Okay, so we got the point 0, 4, 1, 2, 3, 4, and it's going to be closed. And -1, 5, 6, 7, 8. So it looks something like that. Okay, and then the next branch, we're gonna have the point 0, -1. It's gonna be open. And then I'm gonna have the point 3, 1. 1, 2, 3, 1. And then 5, 7/3. 1, 2, 3, 4, 5. 7/3 is so 7/3 is going, so 7 divided by 3 is 2 with a remainder of 1, so 2 1/3. 1, 2, 3, 4, 5. So something like that. It's going to be closed. It's not going to be perfect, so don't expect it to be perfect because it's kind of hard to guesstimate 1/3 on here. Okay, and then I have the line y is equal to 2 for values x is greater than 5. So 2, it's going to be open circle at 2, and then the line y equals 2 looks like that. So they're not going to line up with each other. It's just the graph isn't blown up a lot. Okay, that's actually 2 1/3 up there. Okay, so whenever you have the line y is equal to 2 or just a number right here, it's just a horizontal line. People get confused on graphing that sometimes. Okay, next one. It says evaluate the following given the piecewise functions. So we have to locate what branch these things are going to be in. So f of 7. 7 is located in this branch right here. So 7 times 2 is 14. 14 minus 1 is 13. 0 is going to be located in this branch over here. So 0 plus 5 is 5. F of -1 is located in the top branch. So -1 plus 5 is 4. F of 3. F of 3 is located in this branch because it's equal to 3 plus 5 is 8. Now, as I go through, I want to evaluate the limit as x approaches 3 of f of x. So we did this already in one of the previous lessons. You have to do your left-hand limit and your right-hand limit. So I'm going to plug in a 3 into the top branch. That's your left-hand limit, is 8. As I go to the bottom branch, 3 times 2 is 6. 6 minus 1 is 5. So that means that the limit as x approaches 3 of f of x does not exist. Okay? You should be pretty good at that type of question already. Okay, now we're going to take a look at some a little bit different piecewise functions. We'll put some parabolas in there and some square roots. Okay, so it's still the same exact strategy as before. I have to get some coffee, hold up. Okay, so same exact strategy as before. So we're going to do y is equal to negative x squared plus 1. And we're going to pick points at 0 and less than 0. So 0, -1, -2, and -3. Okay? So if I plug in a 0, I get a 1. If I plug in a -1, a -1 squared is 1, so it should be 0. -2, -2 squared. -2 squared is 4, so that's a -4. -4 plus 1 is a -3. Negative 3 squared is 9. Negative 9 plus 1 is negative 8. Okay. So I'm going to start at the point 0, 1. It's going to be closed. So 0, 1. It's going to cross at negative 1, 0. Negative 2, negative 3, 1, 2, 3. Negative 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's a parabola. So it should look like a parabola. Okay, it's not a straight line, so don't try to make it a straight line. Okay, and then I have the line 4/3 x minus 4. Okay, so make our T-chart. And I'm going to pick some values 0, 1, 2, 3, and 4. Okay, so if I plug in a 0, 0 minus 4 is negative 4. If I plug in a 1, it's 4/3 minus 4. And you get negative 8/3. Plug in a 2 is 8/3 minus 4 is negative 4/3. Plug in a 3, you get 0. And plug in a 4, 16/3 minus 4 is 4/3. Okay, so we're going to plot those points. So 0, negative 4 is down here. 1, 2, 3, 4. And I'm going to plot this point 3, 0. 1, 2, 3. And I'm just going to draw my straight line. I'll get one more point just to make it nice and neat. Up 4, 1, 2, 3, 4, 1, 2, 3, like that. And that's what our graph looks like. Okay. The next line, y is equal to a negative 3 for values less than or equal to 3. Okay. So at 3, 1, 2, 3, 1, 2, 3, we're going negative 3, 1, 2, 3. Like this is going to be a closed circle because the equal to. And I'm going to draw my line y is equal to a negative 3 going all the way out this way. Now, square root. Let's talk about the square root graph. So y is equal to square root of x minus 3. And we're going to pick values starting at 3, 4, 5, 6, 7. Yeah, that's good enough. Okay, so we're going to plug in a 3. 3 minus 3 is 0. Square root of 0 is 0. Plug in a 4. 4 minus 3 is 1. Square root of 1 is 1. 5 minus 3, square root of 2. Square root of 3. 7 minus 3 is 4. Square root of 4 is 2. This is going to be an open circle. Now, what I need you to make sure, like on square roots and stuff like that, I don't expect you to know what the square root of 2 is or square root of 3 is to plot it. You have to be smart and get key points to where you can actually take the square root of the number. So like my next key point that I'm going to get would probably be like 12, because 12 minus 3 is 9, square root of 9 is 3, okay? So that would be the next really good point to get. So we're going to start at 3, 0. It's going to be open, 4, 1, and 7, 2. 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to look something like that. And that's what square root graphs should look like. Okay. And we have another one of these problems. Yeah, that's the last one. Okay, so we're going to look at which branch we're going to be lying in. So f of 1. F of 1 is going to be in this branch right here, so we're going to plug in 1. Negative 2 plus 6 is 4. 0. F of 0 lies in this branch, so 0 plus 5 is 5. F of negative 1 lies in the top branch, so we're going to plug in negative 4 plus 5 is 1. Plug in a 6. 6 is going to lie in the bottom branch, so that becomes negative 12 plus 6 is a negative 6. And then I want to do my limit as x approaches 0. So we're going to do the limit as x approaches 0 from the left-hand side, and the limit as x approaches 0 from the right-hand side. Okay, so the limit as x approaches 0 from the left-hand side is going to be the top branch, so you get 5. And the limit as x approaches 0 from the bottom branch is going to be 6. So that means the limit as x approaches 0 is going to be, does not exist. Okay, and that has been graphing piecewise functions. Hopefully you understood how to do this. Make sure you make your T-chart. Make sure you find your good points. Use the straight edge when graphing your lines. And we're going to be using this in the next lesson. Thanks, and have a good one.